Hello guys, my name is Hitesh and in this video tutorial I'm going to demonstrate Mongo GeoSearch feature with a working example of restaurant search. While doing this, we will also see how Spring Mongo data exposes this capability with a really easy interface. So what do we need to get started? As far as tools are concerned, in this video tutorial I will be using Eclipse IDE with Spring Tool Suite plugin and Gradle plugin. These two plugins are handy while developing a Spring Boot application with various modules like Mongo itself. The version of Mongo we will be using is 3+, as it better supports geospatial search queries. Also, this can be developed on Java 1.6 and above. Moving on, what do you need to know before trying this out? Spring Boot basic concepts and Spring Boot Mongo data concepts come handy while trying this tutorial out. Also, a basic idea of Mongo queries is really helpful. To exhibit this feature, we will build a working example with restaurant entity and perform search queries like find within 20 miles radius. So let's get started. To create this working example, we will need to set up a Spring Boot application, and this is the time when Eclipse STS plugin comes in handy. Let me quickly launch the Spring Startup Project wizard and show how fast we can create a Spring Boot application with auto-configured compatible dependencies. Since we have STS plugin, in the new project wizard, we get the option of Spring Startup Project. This launches a Spring Boot application creation console. So let me quickly complete the first page and move on to our dependency selection page. The name of the project we are keeping as Restaurant Geo Search, and with this we will select Gradle STS as a project management tool, and on a similar fashion our GAV will be Restaurant GeoSearch, artifact would be Restaurant GeoSearch, and you can keep the package name also as Restaurant GeoSearch. The next will be our dependency management selection. To exhibit the Mongo GeoSearch feature, we will need Spring Mongo data module dependency, and for REST interface purpose we will select web dependency as well. With this, let's finish the wizard and create Restaurant GeoSearch project. Once the setup is complete, we will be able to see this Restaurant GeoSearch Spring Boot application within our Eclipse. As you can see, now we have a pre-plumbed, auto-configured project with build.gradle containing all the required dependencies. We also have the package structure with our Restaurant GeoSearch application class already. We will build the GeoSearch feature using this structure and application. To start with, let us create the Restaurant entity class. This will also be the persistence class for the system class, and we are going to name it as Restaurant. For Mongo to pick up this class and treat it as one of the Mongo persistent entity class, we need to use an annotation called document, and this is how Mongo knows that it has to pick up this class and make it the part of the Spring container. We can provide the collection a name, and in this case it will be restaurants. So now when we persist this class within the MongoDB, we can identify the collection with the name restaurants. Let me quickly provide it some attributes, and we will need a ID or a unique key to identify each document within the restaurants collection. And for this we can actually use an annotation called ID. And as you can see, this is from Spring Framework data annotations. So now whenever a new entity or a new document within the restaurants collection gets created, it will be assigned a unique attribute or a unique field with name ID. Adding another attribute to the class restaurant, which is name of type string, and later we will create setters and getters for the attribute. Moving on to the attributes specific to GeoSearch, which is mostly the restaurant's address. To create the address, we will create constructs for address in separate classes or in distinct different classes. So if I have to define address here, I would do something like this. And since I'm using Eclipse IDE, it will give me an error with an option to create a class. So let me create a class called address, and it automatically picks up my package and source folder, and I'm going to do this. So now I have a distinct and a separate class called address, and now address can have its own attributes: private string street 1, private string street 2, private string city, private string state, private string or private int zip code. So these are the normal attributes for an address even in the real world, but the one we are particularly interested would look something like this. So I'm going to create another class here called location. Location geolocation, and using the location class we will try to identify and define the geolocation attributes. I'm going to do the same thing again and create a class location, and the attributes of location has to be in a particular fashion of storing longitude first and latitude second. This is the construct which MongoDB expects to perform the GeoSearch, and let's quickly create the getters and setters for the location class. Let's do the same for the address class. City, all these attributes after geolocation, okay. And let's do the same for the restaurant class. So now we have entirely defined how a restaurant entity look like. So when we try to create a restaurant, it will be assigned a unique identifier ID, the name of the restaurant, and the address of the restaurant. And the way address is defined is we can specify street 1, street 2, city, state, zip code, and to store the geolocation for the particular restaurant we have a construct with a class called location. And the key or the catch here is to store the longitude first and the latitude second. Now when we have defined our restaurant entity class, it's the time to create a class to perform operations on it. So let's get ahead and create a class to perform operations, and I'm naming it as restaurant geo search service. The purpose or the responsibility of the class would be to perform operations like create, find, and for our case we will be mostly concentrating on find by distance, which we will implement. First and foremost, let's make this class available to Spring by annotating it as component and define some methods in it. So one method would be public void create restaurant, and later we will come to each of the method body and the arguments particular method is going to take. And another method would be public list of restaurants, find all. And a similar method would be find by distance, which will also return a list. So once we have defined these operations, we will work on each of these operations and see how can we develop this system for restaurants and perform a geo search on top of that system. Let's turn our focus on the first method, which is create restaurant. So to create a restaurant, we would need the information for a particular restaurant, like name and its address. So since we will be exposing the creation of restaurant through a REST interface, mostly a post, an HTTP post, I will create a different object for the user of the system to pass in to create a restaurant within our restaurant geo search application. So I'm naming that class as restaurant representation, which is the actual object the user of the service going to pass us in. And since this is not there, I have to go and create it. Similar to address and location classes what we created earlier. And this will have similar attributes like our persistent entity restaurant. And I'm going to use the same constructs for address as well. We don't need an ID for this representation of an object because it's just an intermediary object. Finally, we will convert this into the restaurant, and this is exactly how it's going to work. So let me quickly create setters and getters for it. All right, and now we have this. Let's go back to our restaurant GeoSearch service class. So once we have this, we have to create the restaurant object. So we will do something like this. Restaurant equals new restaurant. So this provides me an object of restaurant persistence class. And let me call this as persistence. So we are clear between the representation and the persistence class. And now we can actually do some setting and getting, which will be coming from this. And similarly, the address. And since this is the same address class, it will be easier for us to set and get the entire construct. So from the representation class restaurant, we created a fully populated restaurant persistence entity, which will finally be stored in MongoDB. And now how do we do that? So since we are using Spring Boot as our base structure of the application, it provides you a pre-plumbed or a pre-configured Mongo template or Mongo operations to perform various functions. And it looks like this. And since it is a bean managed by Spring container, it can very well be auto-wired in this class. And actually it's plural. So there you go. And now when we have this Mongo operations, we can perform various functions. So I'm going to say Mongo operations dot save, and you can see we have different constructs for save. I'm going to use the first one, and it says object to save, and this is the object to save. So when we execute this method with a populated restaurant persistent object and use Mongo operations.save and pass in this object, it will actually go to your MongoDB and persist this object. Now when we've created and completed the create restaurant operation, let's quickly create a REST endpoint for it. And for that, we will define another class called restaurant resource. And this will hold or host the various endpoints for our various operations defined in the restaurant geo search service. And to make it a resource, I have to do a few things, which is annotating it with REST controller, providing it with a request mapping, and what request mapping, and which will map to restaurants, which is plural. And we will quickly create an endpoint as well, public void create, and here we're going to take the representation of the restaurant in consideration, and using the create method of the service class actually create the restaurant. Rep and this, and since the restaurant geo search service is a Spring component, it can be auto wired within this class, and which is exactly what we are going to do. Restaurant geo service and auto wire it. So we have a instantiated and initialize service class object, and using the service class object we will do create restaurant and pass in the restaurant rep, and in turn this will create a restaurant entity within our restaurant MongoDB database. Another thing would be to provide it a HTTP method, which is we are going to do through request mapping, and we're going to look for the method and actually say request method dot post. So whenever we perform HTTP post on the restaurant method, this method will be called, and if we pass a well-constructed restaurant representation object, we will see a equally well-defined restaurant entity getting created in our MongoDB. Now when we have at least created one endpoint to create the restaurant within our application for restaurant geo search, it's now time for us to try it out and fire our Spring Boot application up and see if it actually works. So to do that, we have to configure our application a little bit, and the first part of would be to do a component scan on our packages and classes to pick up all those classes what we made and make them Spring container qualified. And to do that, we have to give a base package for Spring to search those classes and instantiate them and cater them in the Spring container. So this being done, the second part for us would be to go to source main resources folder and go to application YAML file and provide some of the configurations for the Spring application to run in. And some of the common ones are Spring application name. You can provide your application a name, and in this case I'm providing it as restaurant system. In similar fashion, you can provide configurations for your data, and in this case we will be playing with Mongo, so you can provide your database name, and this will be restaurant system DB. Another few important configurations is your MongoDB host, which in our case is localhost, and the port where the MongoDB is running, and mostly it is 27017. So this being done and our application class being ready as a Spring Boot application and doing a component scan on the base package com.example, let's see if we can start this application. So I'm just going to right click on it, go to run as, and do a Spring Boot app. Since we already have the STS plugin, the application should fire up. And let's look at the console. It is coming up nicely so far, and yes, so Tomcat started at port 8080. Since we have not provided any port configuration for the Spring Boot app, it picks up the default 8080 port and start up your application. Now that the application is running on the 8080 port, let's move on to the Mongo side of the picture and fire the MongoDB up. You can easily do it going to your command prompt and type a command mongod if your Mongo is already installed on your system, and let's see if that happens. So yes, so Mongo started and it says it's waiting for connections on port 27017. So means the MongoDB is started, is running, and is ready to serve any request coming through any of the channels. So in our case is our Java Spring Boot based application, and to test that I have prepared a small SOAP request through a REST interface. SOAP does provide REST interfacing as well, and as you can see I've prepared this construct as well. So I've named my restaurant as restaurant1, address with geolocation, longitude first, latitude second, and providing those common address attributes. So it's X Street on Washington, state is DC, zip code is 20,001. So let me fire this post on this particular resource and see what happens. Yes, so we get a HTTP 200 OK, means everything went well. And if we go and look into the MongoDB, our entity with name restaurant1 should be created. So let's check that out. Okay, so I'm going to do Mongo, which will give me a client, and I'm going to use the database, which is restaurant systemdb. If you remember, we defined this in an application YAML, and it says switch to the particular database. I'm going to do like show collections. As you can see, there is a collection called restaurant. This is coming from the entity class where we had defined the @document annotation, and we are all ready to do the query on this particular collection. So db.restaurants.find, and there we go. So if you can see, we have the ID, which is a unique identifier, the class from where the restaurant got created, then the restaurant name 1, and address would be populated. And here is our geolocation object with longitude and latitude in place. So with our Spring Boot application in place, through this REST endpoint in the restaurant resource create, and using the GeoSearch service of create restaurant using Mongo operations, and finally a persistent class of restaurant got converted into a MongoDB collection document. ID and can be retrieved, and we can perform all sort of operations on this particular document within this restaurants collection. Now that we have a way to create a restaurant, for the simplicity of demonstration and use, I have created some of the restaurant inside the DB, and as you can see, all of them have the geolocation attribute populated. And the way I have populated this data is around DC area, which is Washington DC. So the longitude being stored first and the latitude being stored second, and I think I have around 6 to 7 restaurants being populated. So let's move on to the next operation or the function on the restaurant entity, which is find all. So we want to create a capability or a method to retrieve all the restaurants without any criteria, and this can be achieved very simply and very easily by using Mongo operations again. So Mongo operations expose or have an interface with a method called find all, wherein you can just mention the entity you want to receive from a MongoDB, and in our case, which is nothing but restaurant entity, and you just need to do this restaurant on class. And Mongo operations is smart enough to go back to the DB and look for all the documents for the collection restaurant. Now we will create the REST endpoint for the find all method. So let's go to our restaurant resource class and create an endpoint for exposing or for returning back all the restaurants. So this will be list of restaurants. It can be very well this. Since it's a get, we might not need the arguments for this as of now. It's going to return me a collection, and we need to provide a request mapping for it. This is how it will be. To request method dot get, and we already have the service object here. We're going to say return service dot find all. And there you go. So now we have a HTTP GET method, which is nothing but an endpoint to retrieve all the restaurants implemented correctly. So let's go ahead and fire up the application again, so all these endpoints are picked up, compiled, and available for us to use. The process is same. We go on the application class and we run it as a Spring Boot application, and the console shows you the progress, how the Spring Boot application is getting started, and then we have the final confirmation where we see that Tomcat is started on 8080. Let's go back to our SOAP UI project, but in this case it's going to be a get, but the resource remains the same and there will be no body. As you can see, this is smart enough to eliminate the body part, and when we fire this we get this, and it's better to look at like this. There we go. So as you can see, we have retrieved all the restaurants in this get method, and whatever there is in the database, I think there are around 6 to 7 records, all of them got retrieved. So using the find all, we were able to retrieve all the documents or all the restaurants within the restaurants collection. Now we want to find a restaurant by putting some criteria into it, and with our geolocation search filtering, that criteria would be distance. So let's get started and see how this geolocation search would work. We would need some parameters to do this search, and those parameters would be a base point in terms of longitude and latitude, and the distance you want to restrict that search to from that base point. So we will need some arguments to be passed to this service method, and they would look like something like this. Float longitude, float latitude, and the distance. So once we have this information, we can base our query we can do the query based on these parameters. And how this will work is we will create a base point, and this point class is mostly provided by Spring Data Geo package, or the Mongo module of the Spring. We will use that and create a base point out of it. Just a new point, and again longitude goes first and latitude goes second. So this is mostly point x comma y, where x is your x-axis or the x coordinate on your 2D plane, and y is the y coordinate of the point again in your 2D plane. So we have the base point. Next would be the distance. So this distance is nothing but the distance value, but we need to provide a measure, a unit for the distance. Again, this distance comes from Spring Framework Data Geo package, and I'm going to call it as radius equals to new distance, and the value would be distance, an integer value, and we can provide it a unit. So I'm using miles, but we have kilometers and neutral, which is again the radians. So I'm going to choose miles, which is more relevant. So once we have this, as you can see, what we're trying to do is from a base location or the center location, and we're creating a radius out of it. So it means we're trying to create a circle search. So again, Spring provides circle again in data geo. This is a class, and I'm going to call it as an area, and it provides a construct where it takes the base point as the center of the circle and radius, which is nothing but the distance class. So we have this area, which is the primary condition for us to do that geo search. This being done, we will use the Mongo operations. Or even before doing that, we have to create a query, and again this query is from Spring, and we will choose it the Spring core query in the data Mongo package. And in this query we will add the criterion, and the criteria here is where, if you remember the construct of the restaurant class, we had an address, so address, and in address we had the geolocation. So we are trying to navigate the cursor to this location in the construct, which is address.geolocation. And now here is the magic. So Spring automatically provides you a method or an interface or an implementation for within sphere, and it takes in the circle as an argument. So we're going to do this, and we will pass in our area as the argument or the parameter to this method. So now we have a query ready, and we have Mongo operations also ready. So we will do Mongo operations.find, and as you can see, the first method or the first construct for this method definition provided is query and the entity class. So we have the query ready. We will pass in the query, and similarly we know the entity class is restaurant. So restaurant.class, and this is really it. So what we are trying to do here, from a base point which is a given longitude and latitude, and within given distance, so within a given radius in miles, we are trying to search on address.geolocation. So this will mostly go to all the records within the restaurant's collection and go to this field and this construct in particular document and do a spherical search within this area and try to find out what all restaurants match this. So let's quickly create a REST endpoint for the find by distance method. So let's go to our restaurant resource class and define an endpoint for this. Public, again a collection of restaurants, and this time it's find by distance, and we will need all those inputs from the user of the endpoint. So it will be request param, so these will be query parameters, and we will be taking in them from the consumer of the service. Long, bear with me while I type this out. So this will be for the longitude, and similarly we will have things for latitude, and one for distance. And this is it. So we have all arguments in place, and for now I'm going to say return null, so the one error goes away. I'm quickly going to provide it as request mapping, and for the sake of simplicity I'm gonna do this. And method will be again a get. Alright, so again we have the service class already present, so let's make use of this service dot find by distance, and we have all the all the three things passed to the service class, and the service class should return us the list of the restaurants within the distance and given longitude and the latitude value. So let us fire up a fresh instance of the application, very similar to what we did for the find and the create. And there we go, so it started. Let's move to our SOAP UI, and here I have already prepared a request. So localhost 8080 restaurants find by distance, so this will give us our endpoint, and longitude minus 77.01 and 38.91. This is somewhere near Washington DC. So let's start with distance 1 mile and see what happens. See, so for 1 mile, within 1 mile radius of these longitude and latitude value, we got just one restaurant returned back. Let's increase it to 3 miles. More results. So within 3 mile radius, it was able to find 2 restaurants. Let's increase to 20 miles. So now when we have the 20 mile radius, the restaurants from Oakton location and the Vienna location also showed up. And if we move this to 100 miles, I think almost all the restaurants will be returned. So we have restaurants from Richmond, we have restaurants from Baltimore, because all these places fall near to like 100-mile radius from what we are trying to search. So this is how the find by distance and the querying part in the GeoSearch service worked with Mongo without we doing much of calculations and stuff. I hope you enjoyed this video tutorial. Please leave your feedback in the comment section. Thank you for watching.